Hello and welcome to our show. Before we begin our discussion today, I must state clearly that the content of this review is generated by artificial intelligence.
Thank you for having me. I'm very glad to be here to discuss this topic with you.
We are here to guide you through a very technical subject. Today, we have a substantial text to analyze. We are looking at the book Mastering API Architecture by James Goh, Daniel Bryant, and Matthew Alburn. It is published by O'Reilly.
It is a fantastic resource. The book is a comprehensive guide on how to design, operate, and evolve API-based systems.
And the authors have a specific audience in mind for this book. They mention developers, enterprise architects, and a group they call accidental architects.
That is an interesting term. By accidental architects, they mean developers who find themselves making high-level system design decisions. They might be excellent at writing code, but suddenly they are responsible for how the entire system connects.
So this book is designed to help them succeed in that new role. To make these concepts easier to understand, the authors use a running case study throughout the chapters.
Exactly. The central example is a conference system. It begins as a legacy, monolithic application, basically a traditional three-tier system used to manage a conference.
But the owners have new requirements, do they not? They want a mobile application and they want to scale the system globally.
That is correct. Throughout the book, we follow the engineering team as they evolve this old system into a modern, distributed architecture.
Our goal today is to analyze this evolution chapter by chapter. Let's begin with chapter 1, which focuses on designing, building, and specifying APIs.
The authors immediately tackle the choice between API types. Specifically, they compare REST and RPC.
How do they explain the difference between those two?
Well, REST, or Representational State Transfer, is described as an architectural style that models resources. It is very common for external-facing APIs.
For example, if you're building the mobile application for the conference, you would likely use REST. It uses text-based JSON, which is easy to understand.
Absolutely. On the other hand, RPC, or Remote Procedure Call, acts more like calling a function on a remote server. They focus specifically on gRPC.
And gRPC is often better suited for internal communication. It uses a binary format, so it is much smaller and faster than text-based JSON.
That is a crucial point. In the case study, the team begins by extracting the attendee service from the legacy system. This introduces the concept of traffic patterns.
Yes, we often hear about north-south and east-west traffic. What do these terms mean for our listeners?
North-south traffic refers to data entering your system from the outside world. A user on the mobile app requesting conference details is north-south traffic.
I see. And east-west traffic?
East-west traffic refers to communication between services inside your own network. When the legacy system calls the new attendee service, that is east-west traffic.
So you might use REST for the north-south external traffic and gRPC for the internal east-west efficiency. To ensure these services communicate correctly, the book emphasizes specifications.
Indeed. They advocate for an API-first design approach. This means you define the specification before writing any code.
For REST APIs, they recommend using open API specifications. For gRPC, you would use protocol buffers.
Exactly. This ensures that the consumer of the API knows exactly what to expect. If you write the code first, you often create a messy interface.
That leads us perfectly into chapter 2, which covers testing. If we have a specification, how do we ensure the code actually follows it?
The authors discuss a testing hierarchy. They assert that unit testing remains the foundation. However, they place a heavy emphasis on contract testing for distributed systems.
Contract testing is a very important concept. In a distributed system, you have a consumer and a producer.
Correct. In our case study, the legacy system consumes the attendee API. The attendee API is the producer. Contract testing ensures the producer does not change in a way that breaks the consumer.
They mention a specific methodology called consumer-driven contracts. How does that work in practice?
In consumer-driven contracts, the consumer defines their expectations. They say, I need this specific field in this format. The producer then ensures they meet that contract every single time they build the software.
So, if the attendee service team wants to change a field name, the contract test will fail. It acts as a safety net for evolution.
Exactly. The text also mentions specific tools for this. They discuss using stub servers to simulate API responses.
And they highlight a tool called test containers. This tool allows developers to start lightweight databases or services in Docker containers for integration testing.
It is very effective. It is much better than guessing how the database will behave in production.
Moving on to Chapter 3, we encounter the API gateway. This deals with the north-south traffic we mentioned earlier. What is its primary role?
The API gateway manages the traffic entering the system. It acts as the single entry point for the customer.
In the case study, as they extract the attendee service, they do not want the mobile app to know there are two different systems.
Exactly. The gateway acts as a facade. It routes traffic based on the URL. If the user asks for the attendee list, the gateway sends the request to the new service.
If they ask for anything else, it goes to the legacy system. It hides the complexity of the architecture from the outside world.
But it does more than just routing. The gateway handles key functions like authentication and rate limiting.
By placing these functions at the gateway, you remove that responsibility from the back-end code. The attendee service does not need to check API keys.
That is correct. The gateway handles it before the request even reaches the service. This keeps the service code clean.
Now, Chapter 4 takes us inside the network to discuss the service mesh. This handles the east-west traffic. How do the authors explain this architecture?
They explain it using the sidecar pattern. Imagine your attendee application is running in a container. In a service mesh, you attach a second, smaller container to it.
This is the sidecar proxy. All network traffic going in or out of your application goes through this proxy first.
Exactly. These proxies form what is called the data plane. They handle the actual data moving between services.
Then there's a control plane, which is a central controller that tells the proxies what to do.
The benefit here is that the mesh handles things like retries, routing, and mutual TLS security transparently.
So your application code does not need to know how to encrypt traffic. The sidecar handles it automatically. They mention Istio and Linkerd as examples.
Moving to Chapter 5, the authors discuss deploying and releasing APIs. They make a very crucial distinction here between deployment and release.
I think many people use these terms interchangeably. How do they define them?
Deployment is simply installing the software onto the infrastructure. Release is when you actually make it live to receive traffic.
You can deploy a new version, but if no traffic is routed to it, it has not been released. This separation allows for safer release strategies.
Such as canary releases.
Yeah.
In a canary release, you direct a very small percentage of traffic to the new version.
If it performs well, you slowly increase the traffic. If it fails, you cut it off immediately, affecting only a few users.
They mention a tool called Argo Rollouts, which automates this traffic shifting based on the error rate.
And to know if the canary is surviving, you need observability. The authors highlight the 3 pillars of observability.
Yes. Metrics, logging, and tracing. You need all 3. Metrics tell you if there is a problem. Logs tell you what the problem is.
And tracing tells you where the problem happened in the distributed system. Chapter 6 addresses a serious topic: API security and threat modeling.
They focus on analyzing your system from the perspective of an attacker. They use the STRIDE model.
STRIDE is an acronym. It stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege.
Could you give an example of how this applies to the attendee API?
Certainly. Consider the threat of information disclosure. The attendee API returns a JSON object with user details.
A threat modeling exercise might reveal that the database contains the user's passport number.
If the developers are not careful, they might accidentally include that passport number in the JSON response.
Threat modeling helps identify that risk so they can filter the data. They also emphasize checking against the OWASP Top 10 Vulnerabilities list.
Chapter 7 continues with security, specifically authentication and authorization. People often confuse these two concepts.
Authentication asks, who are you? Authorization asks, what are you allowed to do?
In the case study, they implement the OAuth 2 standard. They use scopes to manage authorization.
A scope limits what an authenticated user can access. If you have the attendee scope, you can only see attendee data.
You cannot change the conference schedule. The authors also provide a very strong warning regarding third-party integrations.
Yes, they warn against mixing API keys with user credentials. For example, if a call for paper system needs access, it should not have the user's password.
Instead, it should use an OAuth 2 flow where the user grants permission without sharing their credentials.
Chapter 8 discusses redesigning applications to API-driven architectures. They discuss evolutionary architecture.
The idea is that you cannot rewrite a massive legacy system overnight. It is too risky.
They advocate for the strangler fig pattern. A strangler fig tree grows around a host tree and eventually replaces it.
In software, you build new services around the edges of the legacy system. Piece by piece, you route traffic to the new services.
Until the legacy system is no longer needed. To do this well, you want high cohesion, where related things stay together.
And loose coupling, where services rely on each other as little as possible. Chapter 9 looks at infrastructure and cloud migration.
They contrast replatforming with refactoring. Replatforming is moving the application to a cloud server without changing the code.
Refactoring means rewriting the application to be cloud native. The case study ends up in a hybrid state.
This is very realistic. The legacy system remains on-premises and the new attendee service runs in the cloud.
They use the service mesh to connect them securely. Finally, Chapter 10 provides a wrap-up. They mention Conway's Law.
Conway's Law states that a system's design will copy the communication structure of the organization that built it.
If you have 3 separate teams that do not talk, you will build a system with 3 separate components that do not integrate well.
They also discuss Jeff Bezos' concept of Type 1 and Type 2 decisions. A Type 1 decision is hard to reverse.
Choosing an API gateway is a Type 1 decision. Type 2 decisions are reversible. You can experiment and go back.
Architects should spend most of their energy on Type 1 decisions, and they conclude with the necessity of continuous learning.
The technology landscape changes rapidly. Architects must keep coding and learning new fundamentals.
We have covered a vast amount of ground today. It is clear that mastering API architecture is about managing complexity and change.
The technical patterns are all tools to manage that change. I highly recommend that you read the book Mastering API Architecture for a complete understanding.
I completely agree. It is a dense text, but extremely valuable for your career.
Thank you to our friends of the show for listening to this analysis. We encourage you to subscribe for more technical reviews. We wish you to have a great day.